So here's a quick look at a fully electric vehicle, an EV vehicle. This is one of our switch vehicles. Saddleback College has 2 of these, and we have one here at Laguna Hills High School. This is powered, the high voltage battery pack that actually powers the wheels through a traction motor is a lithium battery pack. So this is a 120 volt battery pack when wired in series. But when working on this battery at all, we would have to use those insulated gloves. For example, this battery right now is disconnected. We've taken both the main positive and negative grounds off. And when that was done, we had to use the insulated gloves in combination with the insulated tools to remove those. That goes out these 2 cables here. This is a high voltage battery, so this is DC power leaving the battery and going out this conduit. Running to the back of the vehicle. So this is our control box, and this has a couple different components in it. This is where our high voltage conduit enters from our battery pack. So it does have our motor controller, and in this case with an AC motor, our inverter. That's going to control the direction of the motor, forward, reverse, and how it applies power depending on conditions of the vehicle. We also have our auxiliary battery over here, which is a 12 volt battery system, and that's going to run on all of our onboard vehicle systems, such as maybe our gauges, our lights, turn signals. All our onboard vehicle equipment is going to be a 12 volt DC system. So we do have a low voltage electrical system and a high voltage electrical system. Right here is where that split happens. We can see these would be high voltage 120 volt wires that run to this small inverter box, and that is going to change that, invert it to 12 volt DC electricity that we're going to charge our auxiliary battery with. Here we have an electric vehicle charger, and in order to charge our high voltage batteries or traction batteries, you're going to need some type of electric vehicle high voltage charging system. So we cannot charge those traction batteries with our standard battery chargers. Depending on whether it's powered by 220 volt electricity or just your standard 120 volt wall socket is going to dictate how fast you can charge the vehicle, at what charge rates you can apply electricity to the batteries. But this is what's required if you were going to charge an electric vehicle or a plug-in hybrid type vehicle. Alright, I just want to give you guys a quick overview of the high voltage electric system on this hybrid Honda Civic here. So you can kind of see the similarities between the electric system with this gas electric hybrid and that full electric vehicle I just showed you, the switch vehicle. So if we start back here, we'll go to where the battery pack is located. And underneath this rear seat, we removed the rear panel, and that exposes what would be the control box, and it contains the battery pack, the inverter, and the controller or computer that is going to take our DC electricity, invert it into AC electricity, and then send it up front and drive the motor to actually move the vehicle down the road electrically. So the big orange rectangle over here is our battery pack, and I can tell by this has been replaced by somebody because the Dorman battery is not OEM from the factory. So somebody has replaced this battery before. But right here we have our positive and negative DC leads leaving the battery. So this would be those red and black cables that we saw leaving that blue battery pack on the other vehicle. Okay, and that runs to our inverter, which then takes that DC electricity and converts it to AC electricity and sends it to our controller into the 3 legs of AC and sends those up to the front to drive the traction motor. Also, you'll notice here we have some extra orange cables, and that's going to be our high voltage to low voltage inverter that runs our accessory system, our 12 volt system. And you can see that lead right here under this red cap. That would be running to our positive battery post on our 12 volt DC battery. So we do have a high voltage, low voltage split as well in this control box. But if we follow these 3 wires through the conduit under the vehicle, they're going to terminate up here and run to our traction motor, our motor unit. And if we could see underneath that air intake hose, we would see those 3 different phases of the AC cables where they connect to the drive motor itself. Okay, so we have a battery in the rear running AC electricity all the way up front to our drive motor. But a lot of the similar components, electric vehicles, hybrid vehicles, hydrogen vehicles, if we're using an electric motor to drive the wheels of the vehicle, we're going to need a battery, and the size will change depending on the type of the car. But then we're going to have to take the DC energy from that battery, change it to AC, and control how we apply that electricity to the actual drive motor of the vehicle. So a lot of the same components are involved in electric vehicles, whether it's a little tiny golf cart or a Tesla. So there are lots of similarities when it comes to common components. All right, thanks for watching. Some kill yourself electricity. We gotta be safe. I appreciate you guys tuning in, and I'm gonna get back to reinstalling the rear seat here.